All right. Everybody hear me? All right. So all the really cool stuff was already said, pretty much. I mean, so many really great concepts that I think are really important. I'm going to talk really just about the hardware and about the improvements to the software and the hardware that are coming in the current release for the version 1.0, and then just sort of our general design perspective on how and why we do things from a design perspective, not from like a big picture PhotosynQ perspective. I was going to talk about how we got here and where we are and where we're going, and these are just random pictures of stuff that we've done, but I decided I spent the last 2 weeks trying to get this thing to work for this talk, and that's pretty much all I can think about. And so I'm not going to talk about anything else except for that. And we didn't even quite do it, so failure is kind of the name of the game. But you will be able to see some data, and I'll show you what we've got so far. So our design goal, and our development goal is really that. It's building large global research communities of data and people. And each one of those words is actually really important. We want those communities to be large, hundreds of thousands of people. We want it to be global, right? Not just in your lab. We want it to be research focused, but be connected with the real world. And we want it to be centered in equal measure around data and around people. And there's lots of networks and lots of platforms out there. But I think because of that basic perspective, it really defines the types of features that we make. So there's four. I'm going to tell you sort of about our primary sort of design considerations when we make anything. If it's the hardware or the software, the firmware, there's a lot of components to the platform. And there's really four main things that come up and again and again and again. One is accessibility. Right? You can't have large communities without something that's reasonably accessible. And accessible has several components. One, if you're going to get a lot of people involved, it can't be like $100,000. It has to be reasonably cheap. So cost is hugely dictates how we design the device. Another component of accessibility is usability. Right? You can have a cheap device that takes you 10 hours to figure out how to use. Again, we've failed accessibility. And then finally, it has to be accessible both to the simplest user, the 10-year-old who gets a device in class and is told to do something and now they have to figure it out, to the most complex user, the guy who's going to build new hardware, hack the thing, add a sensor, change the software, and do whatever that it is that they want. Each of those users, we want them to have equal opportunity to do the things that they want to do. User A, because that's 90% of people who use it, right? They don't see this as a project, they see this as the tool, they want to pick it up, use it, and put it back down. But user B, because that small 2, 3, 4% of users like Brad or other folks who are trying to build new tools, in 5 years' time, they're going to be the ones, the tools that they build are going to be the ones that the other 90% are using. So supporting that community is really important. So as a result of accessibility on all of those fronts, being open source is a really critical component and requirement, really, of our development process. So all of our software and hardware designs, all that stuff is publicly available under the freest license we can possibly apply to it. So accessibility is really important. Comparability is also really important, right? So now we get to research and global. How do we address those two components? Comparability is key, right? If I create a project and I want 100 people to be involved, one of those persons might be a 15-year-old in China, and one of those persons might be a professor at MSU. And I need to know that if they both collected data in the same project, that data is comparable. How do you get a 15-year-old and a 52-year-old to make comparable data? That's a design challenge, if I've ever heard one. How do you even get the same? I mean, we've seen this, right? I mean, every one of our projects, just getting two people in the same field to make comparable data is a challenge. But we cannot achieve this goal without comparability. And there is actually a lot of things, a lot of individual features, one by one, that can improve comparability. And I'll talk about that when I talk about this in some of the software. Verifiable, it's kind of like comparable, but it's fundamentally different. It's something that we've delved into a little bit so far, but we have a lot of plans for in the future. You can't build a community, that word, without trust, right? You can shove people together, but it's not a community until people trust each other. And trust means that I believe that what you took and what you collected was reasonable. I know who you are and I know your history, right? Trust is what makes PayPal work. Trust is what makes eBay work, right? Rating systems is what makes those things work, so you know who you're dealing with. So verifiable is really, really critical. Knowing the location of every data point, the time point of every data point, the user, the device, the history of that device, and the history of that user is what's going to make trust and communities happen. And then finally, collaborative. It's kind of like an overused word. But what I mean to say by collaborative as a design principle is if we want communities to form, I'm not building communities, PS. I just build the sandbox in which the communities form. So the best I can do is make the funnest sandbox with the coolest toys in it, right? And hope that someone jumps in and someone else jumps in and say, hey, let's play with this toy together. That's like the best I can do as a designer. So we need to make, should have changed that. So we need to make tools that make collaboration not only possible, which a lot of existing instruments, at least in this space, really don't have that capability. Not just possible. That is the minimum requirement from a design perspective. It needs to be enjoyable. It needs to be a joy. Collaboration should be a joy. When you go to a conference and you meet a colleague studying something similar to you and you sit and you talk for an hour and you geek out, that's a joy, right? That's what science is all about. Science, through this platform and other similar platforms in the world, should be equally joyous. So we need to build the tools to make that possible. So if you get a device and you use the platform and you feel like we're not doing any of these things, come and tell us. Because I'm telling you right now, this is what we're trying to do. And we should be held to account. Don't email me, though. Directly. Post it on the forums. Okay, so let's talk about this thing. So we had a beta device. We talked about how many units got in the world. This is the new one, and many design changes went into this new device. So let me just talk about some of the things. So it can measure all the same stuff as the old one. Who here has used a beta device before? Okay, relatively small number. Okay, I was hoping it would be more. So Phi2, which is chlorophyll fluorescence measurement, and then PhotosynQ and PhotosynQ, they all come from measuring chlorophyll fluorescence in one way or another. Those are a lot of the parameters that Dave and Dan just talked to you about. That's the stuff we can measure now. With a new device, we can measure those same things, no problem, except the accuracy is a little bit better on this one. We can also measure chlorophyll content, same as the old one, so that's cool. We can measure PAR just like the old one, except it's an improved PAR. So we have better correlation and better results in a wider range of light types. So more green light, less green light, more red light. Our PAR is more accurate now. And then we also have ambient temperature, humidity, and pressure. With the old one, all of that stuff was in here. And so you would go out for an hour, and it'd be 30 degrees outside, and your temperature readings would go from 30 to 50 as your hand warmed up to the device. So those types of lessons, those are the things that you learn. But the really exciting stuff is down here. So one, measuring proton motive force via ECS. I'm going to give sort of my, as a non-plant scientist's view on this, right? All of these parameters, they're really all based on measuring chlorophyll fluorescence and then playing with numbers, which is fine and legit. But it's like saying, I know in my car, I know what the oil temperature is, I know what the oil pressure is, I know everything about my oil, right? I know nothing about my battery, but I know everything about my oil. Great, right? This is a fundamentally different measurement. This is like saying, now I know something about my battery, right? I'm measuring something different. I'm looking at something different, both mechanically in the plant and also how I actually take the measurement. And from my perspective, as not a plant scientist, but just somebody trying to pull out interesting data, you can't really fake it, right? This is different than that. And I'm really excited because I think it's going to give us a new set of information for all of the predictive measures that they've been talking about Whoops. Sorry. Yeah. You should, yeah. At least it didn't ring up here, I guess. So I think this is really important. And by the way, there is no, not to my knowledge anyway, there is no handheld device that can measure this, period, in the world, let alone one that's $600. So that doesn't exist. The best device you could find to do this is $50,000 or $100,000, and it's a benchtop instrument. So that is really, really unique, and it's because of people like Robert and Dave and John and the hardware engineers who dramatically improved our signal quality so that we could even see this sorts of things. So there's some technology there. This is a lot simpler, but I think quite compelling, and we saw it in our beta tests. Measuring leaf angle. So now if I take a measurement of a leaf like this, I know that the leaf angle was 30 degrees, and I know that the leaf was facing northwest. I also know where I was on the Earth, and I know what time it was during the day. And maybe in a year we'll know what the cloud cover was on that day in that location. That'd be super cool. Why does that matter? Because photosynthesis data, especially all of this, is completely dependent on light intensity. So if I took that plant in 5 seconds, I hit it and I put it in a dark room, I'd get a totally different answer, right? These are not independent of light. They're very dependent of light. And so plants who adjust their physiology to deal with light, like bean plants who do this all day, right? Well, that has much more effect on Phi2 than anything else, right? So you can't ignore this. I mean, you saw it in Jesse's stuff. It has a huge effect. And so then you think you're seeing differences in Phi2, and you're not. You're just seeing the plant will, right? You have to measure this for a lot of plants to say something meaningful. I think it's going to be really important. We also have contactless leaf temperature in this, right in here. So that'll tell you the leaf surface temperature to within about 0.2 degrees Celsius on a reasonably temperatured day. That probably correlates to stomatal conductance, though it's not measuring it directly. And then finally, leaf thickness. We were hoping to get the real deal in here, but we didn't quite. So you're going to get a general sense of leaf thickness, but not down to 10 microns. So for people who used the device, the old one, you had to take the batteries out. They were AAAs. You had to recharge them. It was a big pain. This one has an internal battery and charging circuit, so you just plug it in just like your cell phone. It has a sensor port, an extra sensor port for all kinds of add-on sensors, and actually we already made a breakout board for that. So if you have, for example, from Omega, you got like a temperature sensor, or you have a soil moisture sensor, or you have a CO2 sensor, and you want to hook it up to this, great. The API already supports you talking to that thing and taking data from that thing. So you can build your own protocol and go add sensors however you want. And then this is kind of trivial, but again, when you actually go through the data that they showed, there's a lot of just variability. There's just a lot of noise. Is that biological noise? Is that sampling noise? It's a little hard to know, but we know that a decent amount of it is sampling noise. Some of that comes from just the old device. You would have to manually clamp it shut, right? And you would press a little too hard, or you wouldn't press hard enough, and that slight difference of a millimeter or two would make a difference in the quality of the measurement, and it would add variability. So on the new device, it clamps using a spring, so you get constant pressure all the time. It also has a little seal here, so you don't have outside light coming in, which is important for some things. And then also, finally, on the old device, you couldn't measure cuvettes unless you had a special add-on, which screwed up your calibration. On the new device, it measures cuvettes like that. It opens wide enough to measure a cuvette. So you can measure a cuvette and a leaf without changing anything. Okay, cool. Software. So we've made all kinds of improvements to software, and if you guys aren't familiar with it, it's pointless to talk about. But we completely redid the Android and Chrome apps, which is how you interface with this device. Everyone's expectation is of Google or Apple quality everything, which makes software development really hard. But that's what it is. And so all of your data will now stay synced all the time. You'll get automatic updates from the servers when they happen in real time. Now you can take images and add notes to any measurement that you take in any project at any time. So if you're out in a field, right, you're taking 300 measurements, you get to 26, and you say, I'm not sure if I could take this or not. I want to make sure to mark it or note it. that it was necrotic or something, then you can do that like in real time, and you can take an image, and then you can come back and look at it later. We worked a lot on this. One thing that we learned from the beta was you can collect a lot of data real quick in the field, but then you can spend 3 months trying to make it look good, right? Because it's very easy to collect bad data, especially if you're not collecting yourself, if you have somebody else collecting it. But even if you're collecting yourself, it's hard. It's sometimes easy to miss bad data points. Or it's easy to put in the wrong number, right? So you go through a field, you take 300 measurements, and you realize when you got done that the last 100 you had mislabeled it all. So now what are you going to do, right? You got to go and clean all that stuff up. So we have a lot of tools in both apps now to be able to address that in the field quicker, and also tell the user quicker when it sees bad data. And then just lots and lots and lots of bug fixes. So this is what we're trying to finish by July, which is when we hope to launch this. We have basically a manufacturing timeline at this point that's not really changeable. One thing that people have requested is private projects. So right now all the data is public. There are reasons why you may want to keep data private. We would prefer that it's public because that helps build the community and encourage interaction. But there will be an option to have private projects by July. We'll also do a better job of providing direct feedback. So if you take a measurement and you accidentally miss the leaf, which happens all the time, it'll tell you, right? Because it knows what a normal measurement is. And it'll say, hey, I think you missed the leaf. You may want to retry that. Again, that's going to save you a ton of time when you get back and you're filtering through 300 measurements and you're trying to find those 30 that missed a leaf. It's a real pain in the butt. And then finally, a lot of users, especially some folks in Malawi, but other folks, are interested in using the platform itself just for survey data collection. So you want to go out in the field, like with Mitch's stuff, they took a lot of just visual data, and that happens a lot in plots. So if you want to go out without a sensor and just collect visual data, you'll be able to do that. Oops. So sometime after that, hopefully as soon as possible, there's 2 other features we want to add, and the top one is really important. We talked about the big goal of what we're trying to do is build or create the space for communities to be built. We don't really have a communities feature in the platform, right? You can make a project and you can share that project with people and you can see your data, but you can't actually literally build a community in the way that you can make a Facebook group or in the way that you can make a Google Plus community. So that's sort of the next step. And the goal of the community is, like a perfect example would be if you're familiar with CGIAR centers, or even, the Ag Bio Research Center would be a good example. A bunch of people who want to share their data, they want to be able to talk in a forum together about what they're doing. And they want to potentially have some amount of control over what gets collected, right? So let's say you're 40 wheat breeders around the world and you want to make a community, but you want to make sure that everybody make sure to specify species, right? Everybody needs to say what species it is when they create their project, right? And if they don't do that, then you go to try to compare the data and you're like, well, it's uncomparable. We didn't all collect the same information, right? In a community, you could say, if you're going to join this community and create a project here, you have to specify species. It sounds trivial, but it's the difference between comparability and not. So I think that's going to be really important. And then also at a community level, you can aggregate the data and look at it all together. So now you can have 500 projects in a community and go look at the data for all 500 projects together and get really interesting graphs like Dave showed you, except we're the only ones who can see those right now because we don't have this feature implemented. So I think this will be really important for groups. And then a dashboard so that we're really trying to show the user the thing they actually want to see. Your projects, projects with interests which are similar to yours, a feed, to say what's happened recently, all that kind of stuff. And then beyond that, we have all kinds of crazy ideas. We're working on a soil spec and a grain spec. Soil spec for measuring carbon in soil, and grain spec for measuring aflatoxin. So adding sensors, if you have sensors, if you have ideas, we're totally interested. Educational modules, I think Brian and Ruby and Steffi will be talking about that later, which is great. I think Dan mentioned the concept of sort of feedback mechanisms in the field. So you could start to provide results to users in the field based on what your research is. And then this relates to the verifiable component, having user and project reputation scores so that the next time when we go to Argentina and we don't know anyone there, how are we going to find our Frank? How are you going to find your Frank, wherever it is that you're trying to go? It's really hard to find Franks. Anybody who's done international work knows that. We used to use that term all the time, like Frank is like the golden boy of like person you'll never find. But it's, and if you're working in your lab, you never think about it. But as soon as you realize the potential for doing research on a global scale, the first problem you're going to have is, like, who's my Frank? I don't have one. This is how you get your Frank, right? You go to Argentina, you say, who's the 50 users in Argentina? Who's the ones with the higher scores? Like, contact those 3 people. Then all of a sudden it works. Then all of a sudden you do something you can't do today. So that's kind of the long-term perspective. So finally, from a development perspective, not only are we open source, which is one thing, but we really, really like to collaborate with people. We really, really want to know what your ideas are, what your applications are, what it is that you want to build. And we would love to contribute to that or try to make that process easier for you or whatever. So just let us know. That's kind of what we're here for. And that's it. Sure.
Quick question. So is it possible to add a couple more dimensions to the community structure? One, can the devices potentially talk to each other? Meaning the users in the same field can talk to each other as they're collecting data, sharing data. Second, is it possible that as this data is pushed back, essentially maybe to your lab or whatever is being analyzed, that the analysis could then push back and guide the user in the field as to, oh, you should be collecting this additional data because it's starting to look walks like a duck.
Yeah.
Walks like a duck, right?
So I'm going to answer the second question first. So I think that's actually a really important point to specify. As from the platform perspective, again, us as the sandbox doesn't get to analyze your data. The whole point of communities is that now you have a group of people who understand your data, have context for your data. We don't. I think the Kramer lab understands the data insofar as plant mechanisms, but we have no idea about bean plants versus corn plants in Malawi, right? So, from my perspective, it's really the community that's going to build those tools to feed back to themselves. So yeah. Yep. Yeah. Right.
Now, we're not promising it now because we don't have the good data we need to actually get there. We have hints that we're measuring important things and we may get there. But I think we're focusing first on essentially breeder because they're able to get the data that we analyze and provide that feedback step by step. But I think it's exactly what we need. We need that data and building up those.
Yeah, and I would just add to that, again, the platform is not going to analyze your data. The community in which it exists will analyze the data and that feedback. The platform will build the mechanism by which you can build a feedback tool, but the analysis will be done by the communities and for this, yeah.
Great. The private sector is currently about data. I guess my question is, this data is collected and identified by who's brought it in, or is it pretty generic? So if you looked at it, you wouldn't know what was going on.
No, you know. I mean, just like anything, people can make fake usernames and passwords and put in codes for all of their data. And they could turn off their GPS. And you could do a lot to try to obfuscate. And we certainly don't prevent that. But we're also, we're not.
I'm just answering the question. These guys start right here.
Yeah.
I got one more
as a developer, a community is just a feature which I implement, right? The community's feature is just the capacity for someone to build a community, look at aggregate data within that community, projects which are in it. All a community is, from a software perspective, is you make a project, right? It has some data in it, and it has a specific goal. Right now, that project that's it. It's just sort of floating out there. A community is just like an object in which you can put projects. Like, here's 500 projects in this community. And the community allows you to discuss with everyone in that community. It allows you to take all the data from those projects and look at it. But those are functions that we don't have right now. So I don't define a community. You guys will define the communities based on the features that it provides to you. So that's kind of abstract sounding, but I hope that is clear.
When you talk about location GPS, I imagine that's more like a cell phone GPS chip?
Yeah, we don't have GPS on here.
You don't have GPS?
On the device, we do not have GPS. We use your cell phone's GPS.
Okay, so if I had an RTK system, I could interface that one.
Yeah, can you interface that through your cell phone? Yes. In fact, that's a huge potential for improving quality. But I think yeah. Anyway, sorry, you were next.
So I presume you guys have kind of abandoned trying to quantify
No, I didn't mention that, but I should have. I did. You can mention it. There you go. Go ahead. Go ahead. No, mention away. Yeah, absolutely. I was up until 2 a.m. trying to get this stupid thing to work, so feel free. True? Yep. 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 I left out things which I haven't actually tested for the most part. So there is more, but I left those out. Yeah. Yeah. Yep.
Antagonistic question. So do you have a mechanism or thought about how to kick people out of the user sphere if they're just collecting crap data or collecting data that's not relevant?
Yep. That's the verifiable question. Once we're able, right now we have a very simple mechanism for tracking user information, like how many measurements have you taken, how many projects have you joined. In the future, we'll know how many bad data points have you produced. There'll be ways for people to say, like, just like when you buy something from somebody from eBay, it's like Uber, yeah. There will be a mechanism there in that. Now, I'm not going to kick someone off unless they're like posting, like pro-ISIS propaganda or something. But like outside of that, I'm not going to actually kick someone off of the platform, but their user status and information should indicate to anyone interested in working them that they might not want to work with them. Yes, exactly. Yeah.
I have a related question because one thing I'm glad you guys are thinking about getting rid of bad information, but at the same time, I'm curious how exactly do you evaluate what's bad or not?
Yeah, I can show you like a couple of really quick examples just to see the types of things that we do. We're very paranoid about identifying something as bad that's not bad, which is easy to do. But here's like a fluorescence trace, like simplest possible thing. One thing that we do is we say, hey, if this is noisy because we use this as part of the measurement, tell the user. If this is noisy, tell the user. Those sorts of things. If standard deviations are above certain levels at certain points, which are critical, tell the user. If this goes in the opposite direction, tell the user. Things like that. Yeah. So for most of these, we have a basic understanding of what these traces should look like. Now, if it looks like this, you just measured a dead leaf. No need to tell the user about that. Or maybe you just tell them like, hey, this is probably a dead leaf. But if we argue about this all the time, Dan and I do. If I'm measuring a field and I'm comparing two populations, and one population, all of the first leaves in that population are dead, do I just not measure them? I don't think so. It biases all my data. I want that data. So we try hard not to screw up. Yep. Yep. stores it on your phone until you get within reception, and then it'll sync it for you. Yep. So it just stores it until you get in. It's on Android only right now. Yeah. One of the things we will. No. Over Wi-Fi or whatever.
So if I don't have reception or internet, how can I store the data?
Oh, I think we're confusing the 2 points. This talks to this via Bluetooth. This talks to the cloud or our servers or whatever via whatever your internet connection is. Yeah, and this will store the. I'm sorry, I did that the wrong way around. And this will store the data, will cache the data until you're in range, and then it'll sync. Yeah. Yep.
For example, if you want to use the GPS capability, you do have to have that. Like, my experiments are all in the field. All of them are in forest. So I do have to have that phone plan on that Android device, right? If I do want to collect GPS location.
No, you get GPS without a plan. GPS is just a thing that you get, separate system. Yep.
The reason why we don't have a more accurate GPS is that if we do that, we can't do the project because the U.S. government thinks that we're distributing the national secrets. We
Yeah.
have to say that we're not doing that. You can add it. We can supply our users with that. With the current law.
But I mean, imagine if remember the Dan had a good plot where it showed all the little points in the field, and you could see all the separate points. Imagine if you get down to below 6 inches, you could really pinpoint the plant location via GPS in a field in real time. That's cool. And I think that they're starting to. I read an article the other day saying that the government's getting not so ridiculous. Yeah. Because I mean, the capability of the existing GPS can go a lot better than it shows. It's just the government restricts you from having more accurate GPS. So. Yes. This one has. It should last about 2 to 3 times longer. There's a lot of factors that are involved in determining battery life length, but based on it has increased power consumption, but it has a lot more storage. And we try to not use the device unless you're actually using it, otherwise it turns off. So it should last 2 to 3 times longer. Right now, I don't know, in a typical field experiment, it's 200 or something, 300 measurements. I don't know what it was for you or for you guys. 300 measurements. So figure 600 measurements maybe, something like that. Sure. Just get the right cable. Anything else? And the booth is over there, and so if you have other questions and stuff, just stop by. And that's it. Yeah. Sure.
Before you go, I want to just make a. I can load mine up.
Oh, okay.
Unless you have it here.
I do.
I want to sum up something, and I want to encourage. Do you know how to do this?
It should just hook up once you hook up this cable.
Oh. Okay. I want. Okay. I want to bring up here because okay. Thanks, Greg and Dan. And I want to especially thank
and advertise the breakout session speakers and organizers, because not all of them are associated directly with with this core group, but they're all involved. Some of them are proposing new, exciting things, and they're going to say a lot of stuff that didn't get said here. So I want to just go through that a little bit and just make a little advertisement for what's going on. So in the section A, there's a session on plant breeding and in-field phenotyping, identifying, so here, Andrew, Karen, Joe, and Dan, identifying abiotic stresses with Jesse, we heard from this, Isaac, Sebastian, crop protection, Marty, Mitch, and Veronica. This is really exciting stuff. You got to see this. I'm not going to be able to see that. That's why. But then in section B, this is an exciting new development here. A group has gotten together to initiate a project to outreach and figure out how to use this device in the platform for educational purposes. I mean, it's a kind of big dream to have students out in the world actually doing real science in science classes, and can we do that kind of thing? So here, modifying the multispec to measure plants, soils, grain, algae, coral, and more. I mean, it was one thing I wanted to emphasize here, and I didn't really get a chance to say it very clearly, but you know, all these little features are added for some reason. Take that one, the ability to take photographs during the survey questions. You can imagine all sorts of things with that, identifying leaf symptoms for diseases, you know, throwing it under the canopy to get leaf area index. All kinds of things are possible. Think about what you might use for your research, and let's see if it can happen. Microbial detection using PhotosynQ platform. Okay, Brad and Amy are here, and this is way cool. They're developing methods to use nanoparticles to detect DNA or other molecules. If they can do that, they can design methods for measuring, for detecting early on diseases and identifying them. And what they're proposing, what we're working on together, is interfacing that with the PhotosynQ platform so that you've got that community aspects and you can relate it to other things. You got to see that. So there are lots of things that can be discussed there. And then I'm going to be here talking about what can we measure with the multispec and what measurements might mean. And it's going to be a free-for-all, anything you want to know. And then how to design the experiments to actually collect high-quality photosynthesis data. And he's the guy if you want to do it. And then analyzing the data, Greg's going to talk about that. So I really appreciate it if you hang around. Yes?
So sorry, yeah, the white ones that are out on the booth now, those are the red room numbers. This is the one that went out last week, and we had to move stuff around. So the updated program is on at the booth. Grab that so you know when and where you're supposed to be.
Okay. A couple more things before you go. So if you want to eat the food, you got to get a ticket, because we're not going to unfortunately, we can't feed the entire university community. So there will be tickets here, out this door. The application forms for the micro grants, there's micro, but they could be mega important, right? They're at the booth. Any questions? Great. Have a nice lunch.